The first method we're going to see to organize data is particularly useful when we're dealing with nominal variables. In that situation, remember, nominal variables have values which are simply quantities. So just about the only thing we can do is count how many times each of those values has occurred, and these are called frequencies. So, for instance, let's say that we have a sample of 40 observations, and the possible values are something that we'll call A, B, C, D, E, and F, whatever those are. Those are not grades. Don't think of grades, because E, of course, is not a grade. It could be just different diagnostic conditions, or different tests that have been done on a patient, or whatever other quality you want to think about. So let's say that the value A was observed in 4 patients. Now, of course, I assume that you know how to compute a percentage, and 4 divided by 40 is 10. So that means that the value A is occurring in 10% of the patients, or of the subjects of our sample. And let's say that the value B was observed in 12 cases. So 12 divided by 40 is 30. So it'll be 30%. Now, if you don't believe me, use your calculator. The value C, let's say, has been observed 6 times. So the percentage there is 15. D is 1 for a percentage of 2.5, and so on for the other ones. So what we have constructed here is a frequency table. It's a table that shows us for each value of the variable how many times it was observed in the sample and what percentage of the whole sample that value was observed in. Now, if you look at this table, you'll notice that there is something strange. The frequency numbers really are all over the place. We will go from 4 to 12, 6, 1, 2, and 15. And remember, this is a nominal variable. That means that the A, B, C, D, E, F don't really have to stay in that order. In fact, this being a nominal variable, there is no way to order those 6 values. Okay, so again, we have put them as A, B, C, D, F just because it's a common way to do it, but that's more like attaching labels. It really does not have any meaning. So in this situation, what we may want to do instead is reorganize the table so that the values are listed in their order of observed frequencies. So we're going to put F first, which was observed 15 times, then B, that was observed 12 times, and so on until little poor D, that was observed only once, under a rare condition or someone really extraordinary. So either way, what we want to do is we want to use the order of frequency if we're going to work with the nominal level. Now, whether we're going to organize the values according to their level of frequency, or whether we want to organize them in any other way, the important thing to do is with the data is first of all to sort them. Notice that in order to find out how many I have of each value, I have to sort them. I have to put all the A's in one pile, all the B's in another pile, etc., etc. Sorting is going to be a very important procedure, a very important way of organizing data, especially when we are dealing with ordered variables. Now, if we do have an ordered variable, we can do exactly the same thing, except that this time, because the values do have a natural order, we don't want to change that order. So for instance, let's say that those frequencies that I just mentioned came from a variable that was ordered, where the observed values of 5, 6, 7, 8, 9, and 10 are real numbers, real observed numbers. Well, in this situation, there really makes no sense to reorganize everything in terms of frequencies, because we want to keep looking at the pattern that we're seeing among the values themselves. Notice that we start from low values, we go to a high of 6, and then down to pretty much nothing, and then another spike at 10. And then up and down pattern is something that we may want to keep in mind and use. Now, one thing that we can do with an ordered variable, however, is look at the cumulative columns, and we can add them in case they're useful. Now, what are the cumulative columns, you might ask? Well, that's the topic for the next video.